Hey Sid, yeah, it's really great to see you again. And thank you so much for the help and also like working together on this YCB refresh of this whole YCB benchmark simulated site.
Yeah, thank you for having me and very excited to be working with you all.
Yeah, since you are the leader, the original founder of the YCB benchmark, so I'm really curious about like what really inspired you at the time to found the YCB benchmark.
Yeah, this happened a while back, so I'm going to go back down memory lane to be able to extract what I remember from it. YCB was really a joint effort between Yale, Carnegie Mellon, and Berkeley. Aaron Dollar at Yale, Peter Abeel at Berkeley, and me when I was back at Carnegie Mellon. I think if my memory serves me right, it was Aaron Dollar who really had the original vision of building a physical benchmark for robotics. Aaron, Peter, and I have known each other for a very long time, and we were all, and perhaps continue to be, frustrated by the lack of common benchmarks for robotics.
Yeah.
And back in the day, in 2013, 2014, when simulation wasn't at the level that it is now, we needed physical artifacts to be able to benchmark. And so everybody had their own physical artifacts, and it was a little frustrating for all of us. And so we decided that we'd take the radical approach. We would all put in some money. It was our own discretionary money, and literally create a benchmark that we would put in a suitcase and send for free to whoever wanted it, right? And so that was the origin of the YCB benchmark. Again, I want to really credit Aaron as well as his postdoc then, Burke Kali, who continues to work on the YCB benchmark to really inspire us to start it off. So that's really what ended up happening. We had a lot of decisions to make, what objects to put in there, what objects not to put in there, how to make sure that the benchmark could be persistent. And honestly, we were very opinionated about it. I remember at that time, Aaron and I had both had young kids. And so our kids were playing around with a lot of these things that you see in the YCB benchmark. It's really funny for me in that my kids are much older now, but I still see their favorite toys showing up in some robot video, and I'm like, oh, that's what my son used to play with when he was young. So yeah, that was really the origin story of it. It ended up being a significant amount of work for all of us to be able to create a benchmark, to be able to support a benchmark, and to be able to socialize it with the rest of our team. So a lot of credit goes to Peter and his team for creating the digital artifacts, first digital artifacts, and of course to Burke, Aaron, and everybody at Carnegie Mellon who worked on it to really support it. But it's been a fun journey.
Thank you. Yeah. So I'm really impressed of, how comprehensive the YCB benchmark is, though it's not that large list, right? And also it's really fun of including all those very favorite toys there. So which one is your favorite toys in the YCB benchmark?
Yeah, there's many of them. Of course, the things that are useful and the things that are really inside my heart. I'd say that the Melissa and Doug airplane model. I know I've
Yeah.
talked to you about this before. That is by far the favorite. I might be able to even find it in our house because when your kids grow up, you still
Yeah.
keep one or two of their toys, and I think that's one of the toys that we've actually kept because it's really nice. From a robotics point of view, what I really like about a lot of the YCB objects is that they're actually challenging to dexterously manipulate.
Exactly.
And they're also involving not just grasping, but also real fine manipulation.
Yeah.
And I think that's what's truly missing in what we're able to do with robotics. Being able to pick something and place it somewhere is nice. It's a good first step.
Yeah.
But to be able to achieve true dexterity and true capability, we need to be able to do fine manipulation. And I think that the YCB object set, even today, challenges a robot's ability to perform fine manipulation.
Totally. Yeah, I can totally see it's still very challenging right now for a lot of the manipulation related tasks there. So I really see that it's really amazing in 2013, right? You funded by CB, right? Still is extremely useful for the whole industry. Yeah. And also, I'm very curious about how has the YCB evolved? And also, if you can also comment a little bit on the impact it has to the robotics industry for now.
Yeah, absolutely. I think YCB has evolved in directions that we never anticipated when we started the project. One of the things that was really important for us was not just to create a benchmark of objects,
Yeah.
but also to be able to create a set of benchmark tests that we'd like these objects to be able to perform. We'd like people to be able to perform with these objects. So we came up with a few, but I think that has really grown since. What's also been very interesting for me is how YCB has become a standard for pose estimation and computer vision algorithms for estimating pose and clutter. Never thought that would be a thing. But it's very interesting how you go to any sort of modern robotics lab now, and somewhere in some corner or somewhere in the middle, there will be these YCB objects, which feel great to me, right? Like I think that's really great. I think one of the things that I really wanted, and this is why I'm so excited about working with you all. We created YCB so that we could democratize robotics. We wanted it to be very low barrier to entry for people to be able to produce benchmarks that were validated. And back at that time, our simulation tools weren't at the level that they are now. But now, thanks to the work that you all have done, we're starting to reach a point where we can actually do meaningful validation in simulation, and that the sim to real transfer, the gap between sim and real, is diminishing, growing smaller and smaller day by day. So maybe a question for you is like, obviously you've created the Lightwheel-YCB data set. We work very closely together on that, and it's deeply impressive. Tell me a little bit about like that journey.
Oh, totally. Yeah. So I would say the YCB also motivated me a lot because when I was starting to tackling the simulation problem for robotics, a lot of the researchers, they would tell me, hey, we are currently using YCB, right? We have really great real sites. But for the sim side, it needs a lot of work, right? There's no collision, it cannot be articulated, right? Is there any way that we can refine the YCB site in order for us to have very good sim to real transfer and also to do very good sim related testing and also learning. So I would say that really motivates me a lot. And when I was first looking at the YCB, so I was mainly thinking about, hey, it's just a plane, right? So it's just a toy plane. So how difficult can it be? But actually, to make all those different type of objects into simulation with very accurate models is still very challenging, right? So let me just to give you a few examples there. So I really like a lot of toys that you selected. And one of the toy is the jar with the different type of boxes inside, right? And I would say to make the jar with the different boxes inside as a rigid body, it is relatively simple, right? You only need the 3D scan of it. But in order for you to have the right collision, then you have to also need to build a very accurate collision meshes. But also, like most likely, you need to use the different type of primitives and other things to approximate the collision to make it, I would say, much compute efficient, right? All those things are very important in order to optimize the collisions, but that's just collision. The other thing is just the lead, right? Yeah, like ideally, you should let the robot to do the same task in simulation as in real. Then basically, in order for us to open up the lead, then there is the thread, right? It's very difficult just to simulate the thread in the physical models in simulation. So we have done a lot of work just to make sure that the threading there is relatively accurate, but also the collision of the threading can be very compute efficient. And when solving the threading problem, then it goes to the inner side of these boxes. So I still remember that when you see the jar with the different type of cubes inside, you're asking us, can I pull out the different type of cubes from inside out to outside? And that was a very good challenge because when we were making it, we were saying, hey, you know what? We would just make all those different type of cubes sticking together inside. We will have a lid like on the top and we can allow people to open it up. But we didn't plan that much to be able to pull out all the different type of cubes there. So I really appreciate you keep challenging us, right? In order for us to really, I would say, to raise the bar again and again to make something that I would say personally we are also very, very proud of. And
Yeah.
that is just a jar, and also that would include all the other type of things there. For example, the scissor, right? So for example, the different type of can we significantly increase the visual, the collision, and the other parts. And I would say totally agree with you on what pull us together about our mission to really through this YCB to democratize simulation to the whole industry.
Yeah, I think that makes a lot of sense. And honestly, we want whatever we're doing to stand the test of time. We want people to be able to use it. And that's one of the reasons why I really enjoyed working with you all, because honestly, anybody can build simulation assets, but it's very hard to build good simulation assets.
Exactly.
Uh, and I've always appreciated your dedication to building good simulation assets. The world is full of simulation assets that nobody uses. And so now, because we're focused on sort of raising the bar on this and making sure that these assets are not only photorealistic, but also physically capable, I think that helps a lot. Maybe another question for you is around, there's so many different simulation tools that are out there. There's Isaac,
Yeah.
there's MuJoCo, there's a few others. Um, how do you see the assets that you're building to cross-cut across all of them? And how do you make sure that, when a new tool comes along that is, the latest whiz bang, it's like, how do you plan to support things like that?
Yeah, this is a really great question. Thank you, Sid. So I really see the vision of the simulation is there is a major few tools there. For example, the SXM, the MuJoCo, right? Potentially a few others. Potentially, for example, Genesis and others, right? So there may be a few very good simulators there, but basically, ideally, we can use each of them to calculate very accurate benchmarks there. Then I would say it becomes a major problem for the for the sim-ready assets to have the consistent, I would say, formats that can support MuJoCo, that can support SSIM, that also can support a few other different type of simulators. So basically, in order to do this, internally, we have built this pipeline, and we actually just open source this pipeline that basically we allow relatively seamless transition between, for example, MJCF to USD formats, which is from MuJoCo to SSIM, and also from USD to MJCF, right? So I really see that deep down, we need to have a layer of transition layer that is almost lossless, right? And that could provide relatively equal transitions among all the different type of assets there. And internally, we have a relatively automated pipeline that we would use our internal format to build each of those sim-ready assets there. And we would use those transition pipelines, right, to make sure that we would convert our digital asset, sim-ready asset, into all the available, I would say, formats, and to make sure that they are all consistent. And the other thing I really appreciate you mentioning there is the high quality assets that's not only visually accurate, but most importantly, physics accurate. I would say for this part, in my opinion, is the most important thing, right? So there is a lot of data in the world, but actually there are not that much high quality data for robotics that we can use. And I really see that the simulation is not only a source of providing data, but providing high quality data. And in order to do this, we also need to get the physical data, physical interaction data from the real world, and then implement it into the sim-ready assets, right? So that together, by working with the simulator, it can generate the correct forces and other physical effects there. For
Yeah.
example, the magnetic force and all the other things there. So I would say on our side, we have done a lot of work there, right? Just to make sure that we have a pipeline to get the physical interaction, to collect physical interaction from the real world, right? And also automatically implement it through the conversion pipeline into all those different type of digital formats.
Nice. Well, the proof of any good simulation asset is how many people use it and how quickly they can use it. So when can people in the world start using the Lightwheel-YCB simulation data set, and how do they go about doing that?
Yeah, I would say right now, yeah, we are very, very excited about that part. And also, I really appreciate your partnership and your leadership from the very beginning on this. So we fully believe in that, in order for us to democratize robotics, democratize simulation, we need to provide the high quality sim-ready assets as high quality water, high quality drinkable water that everyone can access, right? So we are going to together open source the Lightwheel YCB sim-ready assets on our GitHub and also on your YCB site, so that basically I would hope that all the researchers, like all the robotics researchers, all the robotics enthusiasts, right? They can all get access, get free download of these YCB sim-ready assets there, so that they can use them.
Wonderful. Yeah, really looking forward to working with you on that, and also in creating more benchmarks and an ecosystem where people can really share their learnings from these assets and hopefully make these assets better. I think
Totally.
one thing that would also be interesting to brainstorm is what's next, right? There are infinitely many objects in the world that are to be digitized. So how does one go about like prioritizing like what to digitize next with the sort of finite resources that we have, and the fact that you're spending so much time making these assets really capable?
Yeah, thank you so much, Sid. So I would say I would love to work with you much, much further on these topics of how can we build more and more benchmarks and also more and more sim-ready assets to democratize them. And on our side, I would say there are a few major tracks there. I would say sim-ready asset is the beginning, right? But in order for it to generate value, we also need to generate data from the sim-ready assets. So what we are doing is we are actually leveraging the sim-ready assets and all the sim-ready scenes, right? And also through the teleoperation and also the automated data collection in simulation, we are generating the simulation data sets for the whole world, right? So we really hope that through those very high quality sim-ready assets with relatively accurate physics, right, we can generate much, much higher quality data, right? So that ideally this data could be based off the data period, the 90%, if not the 95% of the future data of the robotics, right? So that's the part that we are doing right now. And I really hope that that can also help to magnify the value of the benchmark and also the sim-ready access. The other thing there is, I really think that we need to penetrate into different type of category of use cases there, right? So I really love that, YCB started with home, and I really see that still for home, there are some of the things that we haven't solved yet. So home is a very, very difficult scenario, right? So I already saw Helen's list of the YCB 2.0, and I would say it is more challenging, like much more challenging than the original YCB, right? It has much more deformable and other things there. And also, I would say there are definitely more toys that she is selecting. So that can be one direction of getting more detailed into the home related objects. But also, there's the other type of categories there. For example, the medical industry, right? We are currently working with a few surgeons globally. For example, the surgeons with the liver surgery, the surgeons with the spine surgery, and also the other parts of the surgeons there. I would say still for the medical purposes, it could be a very interesting data set and also benchmark that we can together build, right? So it's
Yeah.
almost like the YCB for different type of industry, for different type of categories, right? And in order to do that, it's not only about productionizing something we already have, rather than we also need to invent certain of the technology deep down in the simulator, in the physics engine, in the sim-ready assets, in the data collection process, in order to fulfill it.
I certainly think that like we need to work on hard problems.
Exactly.
Uh, I think that if I were, I'm wearing my like old man hat, and if I were to critique robotics that's being done right now, I'd say that we don't work on enough hard problems.
I totally
Uh,
agree.
and I think I take the blame on myself, right? Like we need to expose the world to harder problems that are much harder to solve, like surgery, like computational agriculture. I know you're working with
Exactly.
Gilwood Lee at Zordi on being able to simulate strawberries,
Yeah.
like lab automation, like industrial automation, like diesel engines and taking them apart. I think that the world needs hard problems. I also acknowledge that like producing and working on these hard problems in real
Yeah.
involves a very high activation energy. You need to buy the assets, you need to grow a strawberry farm.
Yeah.
And that's where I see your value being so tremendous in being, again, able to reduce the barrier to entry so that people can work on really hard problems, because that's what pushes the field forward. And that's what's going to make our students more appreciative of the existing tools that they have, as well as understand the gaps that they need to
Totally.
address to be able to make these tools better.
Yeah, I totally agree with you, Sid. And also, I would say, speaking of Gil Wu's part of Jordi, I really appreciate, her leadership and also her partnership. So I would say, before Jordi, I know a lot of the farming robotics companies there, but they are mainly solving, the like the computer vision problems, right? Like the navigation problems there. But I would say Jordi is really solving the manipulation problem for the farming industry and even bigger, right? And I would say that's really the hard problem to solve, especially the manipulation with a strawberry. That actually sounds simple from human perspective, but actually very difficult to do, right? Because basically there is a lot of occlusion of the strawberry, right? Like first you need to find the strawberry, then basically there is the stem, there is the other leaves, the other strawberries, probably on top of the strawberry, then it's very, very difficult for the gripper to reach this exact strawberry and then cut it, pull it from this strawberry plant, right? So all
Yeah.
these things are very difficult. So it's not only imitation learning, it's a lot of reinforcement learning, right? And in order to do that in the real world, it's also difficult. So the simulation is actually very, very important. But also, I would say, Jordi, you also gave us a lot of challenges we really love to solve. Basically, it is a combination of deformable and also rigid body, right? You need to be able to cut the strawberry at any place, right? And also, you not only need this in CPU environments, but also in GPU in order for you to train large scale reinforcement learning, all parallelizable environments there. And I would say I really appreciate working with you, Jordi, on the problems as such. It is very exciting for our team. Like every day we wake up, we got fully energized of solving this new challenge that we found last night. So like all very exciting things there. Yeah. And I would say, speaking of the YCB and also the future of the benchmarks there, I'm also curious to see, Sid, you are the expert and leading expert in simulation in academia and also in setting up the benchmarks there. So what would you envision as the next vision of YCB or the next vision of the benchmarks in total?
That was a great question. I would also acknowledge that like YCB was a big team effort, and like obviously a lot of the credit goes to Aaron Dollar and Peter Abil. The three of us. I'd love to get the gang back together and work on it again. It's been a lot of fun. I guess like facetiously, I'd say that like my kids were 5 years old and now they're teenagers, so
Yeah.
maybe it's time to add some teenager objects to this. But in a more serious sense, benchmarks have seen tremendous applicability in self-driving, for example.
Yeah.
Like if you look at the Waymo Open data set, we've all benefited greatly from it because it pushes for clarity not only in the data sets, but also in the evaluation metrics. We're able to align on evaluating them. So from that point of view, I think that I'd like to go back to the point I made before of we need to work on hard problems.
Exactly.
And I think that like just like there was YCB for home objects, I think being able to think through what does YCB for surgery mean? What does
Exactly.
YCB for lab automation mean? There's a
Yes.
huge, huge industry in laboratory automation and being able to automate like drug manufacturing, being able to automate physics experiments. What does that mean? What is YCB for like engine maintenance and tasks in an auto shop mean? I think the thing that really appeals to me are the things where there's a finite set of items, but there's an infinite set of tasks that you can perform with them. This is why I really enjoy playing around with your kitchen environment,
Yeah.
because there's just, there's 30, 40, 50 assets there. But the factorial number of things that you can do with those assets is what
Yeah.
makes it incredibly challenging and appealing. I also think that we need to find tasks that are appealing to us, both from a high level planning point of view, using like language models and logic, as well as at a fine manipulation point of view, where you really have to think about forces and contact and touch. And the most beautiful tasks are the ones that force you to think all the way along the spectrum, from the high level to the low level, and make sure that you understand and acknowledge that, right? So I think the sky's the limit for what we're able to do. I've been incredibly impressed with the fidelity and the utility of the assets and the simulations that you're building. So I'm just looking forward to just working on more. So I think all of those are really interesting directions to pursue.
Thank you, Sid. Yeah, totally. So I kind of see the benchmarks can also be a playground, right? So basically, we have you have already built the playground of home, right? The home related tasks for the industry, and there can be the playground of the medical research, the playground of the live automation, the playground of different type of industries there. And in order to build a playground, I would say the real physical eyesight, it could be relatively limited, right? Because in the lab, for example, the medical space, it's very difficult to do the real benchmarks. But I would say the simulated benchmarks probably becomes more and more important. So I would say I'm really, really excited, to keep partnering with you, right? Even further to build playgrounds in sim, right? For the different type of industries, so that we can together to help to democratize the robotics and also the simulation together.
Awesome. Well, thank you so much. And this is a really fun chat, and I'm looking forward to a lot more.
You too. Thank you, Sid.